Welcome back. This is the third session of the CBT. Alright, so I explained to you that the packet we initiated from our laptop for the web page, it reached XEN host, it got redirected and got sent through the forward chain towards VM1, but because of this rule the packet got rejected in the middle and it never reached virtual machine 1. Now there are two solutions to this, both temporary. One is that we delete this rule altogether, or we add our own rule which should come before this rule, and one of the easier ways is to add that rule in the top of the chain, because adding at the top is easier compared to adding it on a specific rule number. Right, so at the moment I would select to delete this rule. And how do I do that? I can do that by removing the -v, so I see a simpler output, and I know that I have to remove this rule, the second last rule. And there is an option, if I can check man IP tables, which is man is not here, so man IP tables on my laptop, I can check that /line /line number. Okay, so I can add this switch. This is for your ease of understanding. I can use this, and I see a line number added to each chain, each rule within each chain. So the rule which I want to delete is this one, which is rule number 5 in the forward chain. So here's how I would delete it. IPTables minus, this is a filter table, so I don't need to specify it. Delete from forward chain rule number 5. Press enter. Check one more time. Since the rule is deleted, so the last line has moved up to 5th position. This rule number 6 is now moved up to rule number 5, and rule number 5 has got deleted. Alright, so I can check with -v. That rule is not there anymore, otherwise it would show me its own stats or the rule counters, which was 1 and 60. It's not there. Let's try to reach our 201 again. See, private VM1 inside a XEN host. This message, I use the address of my XEN host, but the message is coming from my virtual machine 1, which is inside my XEN host. So according to this diagram, I was able to initiate a web request from my laptop. It reached here, got dnatted, sent through the forward chain and reached VM1, and VM1's web service responded with a web page, and it traveled all the way from the forward chain and through the masquerade chain and then reached back my laptop. Before I explain the rules, let me very quickly show you VM1. This is the TCP dump window, and you can see that there is a request coming in from 192.168.1.2, which is basically my laptop. It's not 1.5 as per diagram, because I am on a DHCP in my home, so I get random IP addresses. So 1.2 is my laptop at the moment, and it is trying to reach 122.41 for port HTTP, and this is the starting packet. Then 41, it responds. If I can expand this window, okay, the 41 is responding back to this .2, and it's sending an acknowledge signal, whatever the packet is, and then the transaction and handshaking and the rest of the transaction for this web page is shown here. Okay, alright, so I minimize this and now check the rules again. What has happened so far? Let's start with -Dnat -v. So there are now two rules which have crossed the Dnat, rule, and it went to, or it got redirected to 122.41. And we check the normal filter table by removing -Dnat and check the stats. So the packet got sent to the VM1. It did not match any of the rules here. The packet, remember I'm talking about the packet which started from the left side and going towards the right side. None of the rule matched here. It went through the default policy, which is accept. You see, this one packet has crossed the default policy because it could not get trapped or matched against any of the rules defined in that chain. So the packet reached the other side. We are not following or not checking the IPTables stats on the virtual VM1 itself, but we have already seen the TCP dump output, so that's enough for our satisfaction. Then the web page from VM1 got sent back, and when it's coming back, it's basically, let me show you IPTables through IPTables save which rule it got satisfied through. The packet is coming in through, let me show you only the forward chain, and the rules above also stays. Okay, so this physdev rule has not seen any traffic, although the packet did come through physical device of the bridge from virtual interface 1.0, from the port virtual interface 1.0. However, it did not show you any stats here. Alright, didn't show you any stats here. Okay, this is because of a reason which I've already explained in my paper. Next, remember we are talking about the packet coming back from VM1 as a web page. So the second rule says if the destination is 192.168.122 and outgoing interface is virtual bridge 0 and state is related established, it has seen some packets. That is because when initial communication or handshaking is done, then when the packet goes towards this machine for the third time, naturally it then satisfies this condition. That is why you see packets coming out towards the VM with the state related and established. Then you also see that the packets which are starting having the source address as virtual bridge 0, they are shown as accepted. And remember, there is no state mentioned here. These are the packets, this is the actual web page which is being returned that matches this rule, because naturally the web page is coming from this source IP address 192.168.122.41, and it's also coming in from virtual bridge 0 interface. That's also true. So that is exactly why you see 5 packets coming in from this interface, and you don't see any other accept rules and other reject rules catching any traffic. Okay, so this is one way that you can remove the reject rule. The other method is that you can add a specific rule. Let's say something like this: IPTables minus insert, because we want to insert and at the top you just say insert forward. We do not specify a position number, so it will add at the top of the forward chain. Insert the rule in the forward chain, and the rule is that if the outgoing interface is virtual bridge 0, then accept that simply. Very simple, isn't it? So now our this rule should cache traffic going from the left side to the right side. Let's see. -v. This is our rule just added just now. Let's try to reach our VM again. Okay, it worked. I don't need to show you the Dnat rule because it definitely worked. I will just refresh this command and you see that there are 6 packets now which have matched this rule. Let me show you. Like this. You see, this first rule is now this one. In the forward chain, the first rule is that any packet going out to virtual bridge 0 should be accepted. So our packet initiated from this laptop went all the way to XEN host, got dnatted, got forwarded towards virtual bridge 0, and that is exactly what this rule says. It doesn't have any other condition, but the only condition that the packet is going towards virtual bridge 0, it should be accepted. That is what has happened, and this is why that our packets have traveled through this chain, forward chain, and traveled through this rule, satisfied this rule, and reached the VM. Alright, so now the point comes that how do we make this automated? How do we make sure that when we reboot our XEN host, or whenever we start up our XEN host and the VMs are also started, then the traffic would automatically flow from outside to inside and from inside to outside as well? And how to take care of these LibVirtual rules or IPTables rules added by LibVirtual service. That is what I am going to show you next. However, before I show you that, I want to add one complication to it, and I am going to discuss the poor man's setup, which is at the bottom. The poor man's setup, it basically states the same scenario which I've discussed with you just now. It has another virtual machine. Now what is the complication in this second virtual machine? The IPs are kind of same. Forget about this public IP here. We'll replace it by 1.201, which is our IP at the moment in our lab here. Now port 80 traffic, you are at the moment redirecting it to VM1, and that's working properly. However, what if this is also a web server? Although in the diagram it shows 25.110.143, but it has a webmail interface as well, which definitely needs to run on a web service, and that web service by default runs on port 80. So both of these virtual machines are running web services or web servers. Here the user or the web server, it needs to access, or you need to redirect, or you want to redirect any traffic coming in for port 80 to virtual machine 1, any traffic coming in for port 25, 110 and 143 to the second VM. But what about if the user wants to use webmail? Then what would be the mechanism? Of course, you cannot redirect port 80 traffic one time to this one and the other time to this one. Cannot be done like so. So the solution is that you configure another port on the left side, let's say port 8080, and forward that port to the second VM on port 80. In that way, by configuring two different ports, you can separate the traffic and send it to two different VMs. On the web server side or the site visitor side in his browser, you have to mention the extra port. I'm going to show it to you next. Let's see how many virtual machines are running, and let's start VM2, and VM2 is mimicking a web server. So we have a very simple this. We have a very simple web page announcing itself as a webmail web page. It's not, but I have not configured squirrel mail on this, but it's just a web page serving the purpose. Alright, I log in and I show you the web page, which is various www.html index.html. It says webmail on VM2 inside a XEN host. That is all we need to see in our browser, and its service is currently running. Just need to see status. It's working. Alright, minimize this, back to our XEN host. Okay, now what? If I want to access 201 with port 8080, there is no port 8080 running on XEN host, and there is no Dnat rule, so XEN host will not redirect it to anywhere. Thus you get this error. Okay, now how to configure that? So that means we have to configure a Dnat rule on the pre-routing chain. Here is how. I will recall the Dnat rule pre-routing like this, Control R, and type in few characters which would match the previous command. Alright, IPTables -Dnat -add to pre-routing, Ethernet incoming interface is Ethernet 0, protocol TCP, destination port 8080. Dnat it to destination 42, port 80. If you don't specify port 80 at the end, it would try to reach port 8080 on this virtual machine, which is what we don't want. We cannot just go on and configure each web service with a different port. That would be horrible configuration wise. Anyway, add this rule, check the rule set, and you have two rules now in the pre-routing chain. Dnat simple port 80 to 122.41, Dnat port 8080 to 122.42 port 80, nothing else. And we already have our forward rules configured properly, which don't need any tweaking. Therefore we'll just let them be there and watch what happens. Now I'm trying to do 201, and see, the moment I pressed enter, it reached webmail on VM2 inside the XEN host. And if I do not supply this 8080, I reach VM1 inside the XEN host. That's perfectly alright, and that's working properly. Okay, so there's nothing much to explain about it. It's a very simple concept. Port 80 is reaching VM1 and port 8080 is reaching VM2. Now you might be thinking that who on earth would assume that the second VM is running on port 8080? Well, this is a very limited setup, and this is such a setup in which you assume, let me show you, in which you assume that there are limited web services running on the VMs, and you know how to manage them. And one of the reasons is that you can configure your main index.html page, which is your main page or front page of your main website, running on default port 80, and you can add an extra message like click here, click, and h reference is http://192.168.42:8080 here, to log on to webmail interface. Let's say it's a company, so I would say log on to company company webmail interface. This is what my message is. Okay, so if I reach my web port 201, I get this message, private VM1. This is the main page, and you can always specify this link somewhere. As you can see at the bottom, it shows me the second link. So I'll click here, and I would, oh, sorry, there's one mistake. Where did I do that? I incorrectly mentioned. That's why it's trying to find 122. It's not that. For the public, it's still 201 on port 8080. Internally, whatever it is, we are not concerned. Okay, let me refresh. Alright, this is the same page coming from VM1. This is the link, and it says 1.201 port 8080. If I click here, immediately I'm taken to so-called webmail interface, right? So this is how you would use such different port numbers to forward to different VMs. This is appropriately called poor man's setup. Why? Because you do not have multiple IPs here on the left side of your Xen host on the physical interface. So you cannot use IP to IP mapping. So you are restricted to using a specific port and being forwarded to a specific VM, and another port being forwarded to another VM, etc., etc. So this kind of setup, poor man's setup, is ideal for those who do not wish to buy an extra IP, or who have just, let's say, a very minimal set of virtual machines. Suppose one virtual machine here and one webmail here, and both have very separate interfaces or very separate different port requirements. So this can be done. However, if there is more virtual machines and there is more traffic to be reached, then poor man's setup is not for you. You have to be rich for doing that. And what is that? That rich thing is something like you have extra IPs on the left side, and each IP is mapped on a separate VM without specification of any port whatsoever. So if a web user reaches port IP 41 on port 80, it gets here, or redirects to this virtual machine. If it tries to reach .42, whatever the IP is, .42, it is redirected to VM2 without specification of any port. I'm going to cover this next. However, before I cover that setup, I'm going to show you how you can make it fixed, so the next time your server starts, you can have these rules in place. Now this is important, really important. This is the essence of this CBT, and to cover that I would like to have another session, or I would cover that in the next video. I would stop this here, and I will show you how to make it permanent in the next video. Hold on, stay with me.